All right, everyone, here's the review for our Unit 8 Part 1 test. Hopefully I'll go over everything so you don't have any questions and everyone can do well on the test. So on question 1, obviously this triangle has been turned, but we are going to use the Pythagorean theorem. Okay, so as everybody remembers when we talked about Pythagorean theorem is a squared plus b squared equals c squared. All right, and remember we talked about leg squared plus leg squared equals hypotenuse squared. So if you have both legs, now remember the legs are where the right there they meet to form the right angle. Okay, so here's your right angle symbol, and it's the two lines that meet. The hypotenuse is the side opposite, okay, right there, the longest side. Now, remember we talked about if we have both legs, then we are going to add. If we have one leg and one hypotenuse, then we are going to subtract. All right, now you can set it up the same way and then just do it algebraically, or you can take the shortcut. So in this particular case, we have both legs, so and it doesn't matter which one you put where, as far as in the problem. So we've got 8 squared plus 15 squared equals c squared, and then we're going to get 64 plus 225 equals c squared. So 64 plus 225 equals 289 equals c squared. And now we're going to take the square root of that. So you hit your square root button and you get 17. Okay, so your answer for this one, the length of AB, is 17. All right. On question 2, same thing here. We have the leg here, and the leg here. So we're going to go, and then we need the hypotenuse, the length of AB. That's what they're looking for. So we're going to go 4 squared plus 7 squared equals c squared. And then your calculator, 4 squared, which is 16 plus 49 equals c squared. 16 plus 49 equals 65. Right? Equals c squared. We take the square root, hit your square root button, and you get 8.06. Okay, I'll let you know. Don't get hung up on your decimal here. If it's somewhere close, if you round it up, that's fine. 8.1. Okay, but I'll let you know on the test, and I won't mark it wrong if it's rounded up to 1 or rounded down. Okay. So let's look at question 3. Question 3 is one you're going to see next unit when we're talking about finding the volume and surface area. But within this cone here, we can draw a line right from the top down to the bottom here, and then we can go right to the outside of the circular base, okay? And that forms a right triangle as indicated here. So we have the hypotenuse here, which is also known as the slant height, and we have one of the bases. So remember we talked about in the first part, okay, if we have a leg and a hypotenuse, we are going to actually subtract them. So I'm going to get 18 squared minus 7 squared. So you're going to get 18 squared minus 7 squared equals 275. And then we're going to hit your square root button, and we're going to get 16.58. Okay? 16.58 or 16.6 is fine if you have 16.6, if you just round it. Probably on the test we're going to round, but I'll let you know. And even if not, just round to one decimal place unless the instructions say otherwise, and if not, don't stress about that, because I can see if you have all this work, I know you did it right, and I'm not going to count it off if you put 16.5 or 16.6. Okay. Make sure you include your units, please. Inches. Now, this is not squared because we're not dealing with area, so it's just inches. This one would be inches. If it doesn't include a unit, don't worry about it. Kind of question mark. Okay. All right, let's go to 4. Let's see what that one is. Another. All these Pythagorean theorem ones, you're going to have a right triangle somewhere. You just got to be able to see it, whether it's obvious or not. Like in this one, it might not be so obvious, but at least they've drawn it out for you. All right, number 4. So we've got from here to here, okay, which is 20, and this is the hypotenuse. So this is going to be C, and we're looking either for A or, in this case, and this is B. So, we're going to subtract again, so we're going to get 20 squared minus 15 squared. Right, so in your calculator, 20 squared, 400. Okay, 400 minus 225. 400 minus 225, 175. Alright, then we're going to hit your square root button. It's going to give us approximately 13.2. Okay? Now remember, one way to check is to make sure that the hypotenuse is always the longest side. At least that'll give you an idea. If you have one of the legs that's longer than this, then you know it might not be right. Well, you know it's not right, and you need to go back and check. Okay? Let's check. Let's go back and check ours. 8, 15, 17. Remember, what's that one called? 8, 15, 17, right? Pythagorean triple. Don't forget that. All right. So, let's see. All right, so let's look at number 5. Mrs. Jones just installed a stone border along the hypotenuse of a flower bed in her rectangular garden. The stone border measures 30 feet, which is closest to the width of Mrs. Jones's backyard. So, don't get hung up with all the rectangle around here. Just look at the triangle, right triangle they have here. Okay. Not very good. All right, we have 24 and we have 30, so we're trying to find that one. This says W, but it could be A or B. The variables don't matter. It's just, that's why we'd say hypotenuse minus leg. Hypotenuse squared. 30 squared minus 24 squared. So in your calculator, 30x squared, which is 900, minus 24x squared, which is 576, equals 324. And then we're going to take the square root of that, so hit your square root button, and you get 18, another triple. So we get 18 feet. 18, 24, 30. Hypotenuse is the longest side, so we're good there. Let's go down to number 6. Now, no picture, so remember what we talked about. We talked about if it's just words, a word problem, make sure you draw a picture. So it tells you, in a right triangle, what's the length of a hypotenuse if the lengths of the legs are 5 and 12. So we can draw a picture, okay, just like that. So we have, it doesn't have to be to scale, 5 and 12, and we're looking for C. So remember, we have both legs, we're looking for the hypotenuse, so we are going to add. So you're going to get, that looks like 52, sorry. Let's go 5 squared, a little tiny square up there, how about that, plus 12 squared equals C squared. So in your calculator, 5 squared, which we know is 25, plus 12 squared, we know is 144, okay, equals 169, which we got a good idea that that is a perfect square, which it is, which equals 13. So the hypotenuse is 13 inches, okay? And we see that it is longer than 5 and 12, so we should be good there. What's this one called again? Pythagorean triple. Let's go to question 7. Now remember, this deals with Pythagorean triples, but it also satisfies, it means if this squared plus this squared equals this squared, then it is a right triangle. Okay? So remember, it's always listed in order A, B, C. So in the first one, we're going to go 5 squared plus 12 squared. Does that equal 17 squared? So on a calculator, we can go 25 and hit the x squared button, which is 625, plus 144 equals 769. Now, when we hit that square root button, if it takes us back to this number, okay, then it's correct. Or you can just say 17 squared equals 289, and that's not it. So we know that can't be it. Okay? So let's try B. B says 10 squared plus 24 squared should equal 26 squared. If it does, then it is a right triangle. So in our calculator, we're going to go 10 squared, which we know is 100, plus 24 squared, which we know is 576. Okay? And we know that gives us 676 if, oops, should be a 6. If we hit, so if we square that, it should give us 26, and it does. So stop right there, look no further. That is our answer. Sometimes you got to go through all 4 of them to find your answer, but we know that 26 squared is 676, which is what those two equal. So we know that it is a right triangle. So you will have some questions on the test where you're just identifying the different parts of a right triangle. And remember, we talked about this leg. I don't know if I can make this a little thicker. Can I make that a little thicker? Thinner, I mean. Maybe you can't even see that. Maybe like this. Good. Leg there. Leg there. So they want to know the hypotenuse. Now this is how we name the hypotenuse. We name it from one starting point to the next. Okay. So they're asking for, we know that this line is the hypotenuse. All right. And we name it by the 2 end points. Okay. So L, it doesn't matter which order, they're going to, LJ or JL, so you just have to look from that. So this never identifies a line segment. So we know that can't be it, right? So anytime it has 3, that's naming an angle. So we know that can't be it either. So it's got to be QL or LJ or JL. So we know LJ or JL, that this is going to be our answer. Okay. Again, naming parts. Which correctly names one leg? Remember, lines, all right, these lines make up the legs and the hypotenuse. So a line segment is going to have 2 letters, the 2 endpoints with a line over top of it. These are naming angles. So I know right away I can take one of them, take those out. So 2 legs, right? This is a leg, and that's a leg. And they just want to know, name one of them. So it could be AZ or ZA, AZ or ZA, no. AP is the hypotenuse, so we know that can't be it. Oh, what's going on here? That's the hypotenuse, AP, hypotenuse. We know that's a leg. and that's a letter. Okay, so it has to be ZP or PZ, right? Because we start up with Z and P, so our answer would be that. So on the review, the first 9 questions had to deal with the Pythagorean theorem. Now, you might see the Pythagorean theorem again once you get to questions involving side lengths and having to find area and perimeter. But just the straight Pythagorean theorem questions are 1 through 9. And now we're moving into area of irregular shapes, composite shapes, area and perimeter. So remember word problems. Katie is going to carpet her living room floor and drew the diagram shown. What is the minimum number of square feet of carpet she will need? What that means is how much carpet will she need to cover her floor? Okay, I'm not going to shade the whole thing in, but that's what it means. Buy carpet and you roll it out. So this tells you it is an area question. Okay, so we can break it into 2 different. Again, it's up to you how you want to break it up. Okay, so we can go here with it. Okay, and then we can go here. Okay, so those 2 figures right in there. All right. Excuse the shade if I got it thicker. So those are the 2 figures that we have. So for this one, remember it's 2 here and 6 here. So remember the rectangle formula is base times height, length times width. So for this one, we're going to go 6 times 2, which equals 12 feet squared. Okay, so we've got that one, and then we need this one. Now, this looks like a perfect square, but we're not sure. Okay, it looks like it, but again, remember computer graphics could get confused, maybe not look exactly what it is, but one way to figure it out, if from here to here is 2, from there, right, from here to here is 2, then from here to here is 2. Okay, so if this is 2 from here to here, and the whole thing from here to here is 5, what is this section of it? That section of it would have to be 3. So we do see that it's a perfect square, and square is side squared, or base times height, however you want to do it. So 3 times 3 would be 9. Now we need to, it's 1 room, so we need to combine these 2 right here. So it's going to be 12 plus 9, and we know 12 plus 9 is 21 feet squared. So she's going to need 21 square feet of carpet. All right, question 11. This spring, Robert wants to purchase grass seed. Before he can make a purchase, he must determine the area of his yard. Now, it looks like a pencil or maybe a house or a rocket ship. I guess that's his yard. So they've sectioned it off in 2 different shapes, this triangle and this rectangle. Again, we know that it's an area question. All right, so we've got this triangle, and we've got this rectangle. Okay, and we're trying to find the area of each one. So in the triangle, we know triangle, formula for a triangle is 1/2 base times height. Okay, and we know a rectangle is just base times height. Okay, so I'm going to plug the numbers in here. Now, if this is 5 from here to here, then what's this going to be? 5. So that will be our base. All right, I don't have the height in here, but I do have the total height. Okay, and I know from here to here is 10. That means from here to here is 10. So if this is 10, this whole thing is 18. I'm going to do 18 minus 10 to get 8 up here. So I know the height is 8. Okay, and then for the rectangle, it's just 10 times 5. All right. So here I'm going to get half of 8, which is 4 times 5, which is 20, and 50. And I'm going to add those two together, and I'm going to get 70. It doesn't even give me units. So 70 units squared. Could be yards, could be feet, but that's not a big deal. If they don't give it to you, that's fine. All right, question 12. What is the area of the figure below? Now, this is one of those composite shapes that we are going to have to make cut into pieces or slices to make different regular shapes that we have formulas on your formula sheet. Now, here's what I'm going to do. It's too thick. You can do it two ways. We can cut it here, right, and make a rectangle and a trapezoid. Or you could do the same thing, just do it over here and make this one and then this one. Doesn't really matter which one you do, you're still going to get the same. You could go, I guess you could go here and then here to make that, to make two rectangles and a triangle. That's just however you see it, that's how I want you to do it. Okay, as long as you incorporate all three shapes or both shapes to get everything inside here. All right, so I think I'm gonna do, I'll just do that one, okay? Because I know I got a 4 by 12 rectangle, okay? So the rectangle equals 4 times 12, okay? Which is obviously 48 meters squared. And then I've got the trapezoid. And the trapezoid formula says 1/2 times the height. Now this is the height. From here, the height of the trapezoid is from here to here. They don't really give that to me, but they do give me the height of the total, okay, which would be 9, and they give me the height of this one, which is 4. So I know that 9 minus 4 would give me this one, which would be what? 5, right? Because 5 and this part is 4. That would give me 9. So now I have the height, which is 5. And then it says base 1. And if this length is 12, then I know this length is 12. And I have this length, okay, which is 5. So this could be base 1, this could be base 2. So that would give me 12 plus 5, which equals 1/2 times 5 times 12 plus 5 is 17, right? And then 17 times 5 should be 85. And then half of 85 is 42.5. So 42.5 meters squared. That's our answer there. All right, question 13. Juliana wants to string lights around the entire edge of her deck. To the right is a drawing of her deck. How long does the string of lights need to be? So that deals, how long does it need to be would mean it's a perimeter question. And that means, let's do green. That means we are going all the way around the outside of this deck, or this H. So what we need to do is fill in some missing pieces. So I know if this is 12, then this has to be 12. Okay? And I know if this is 5, then that has to be 5. And I know that these two are the same, so that's going to be 5. And I know if this is 4, then that would be 4. Right? That's 5, that's 5, that's 5, that's 5. If this is 3, then that needs to be 3. And if this is 4, then that will be 4. Now I just go and add them. Just don't forget where you start from. I'm going to start with the 3. Plus 12 plus 3. Now, when you're adding, make sure you don't forget about these inside parts, because that is perimeter. 4 plus 5 plus 4 plus 4 plus 12 plus 4 plus 5 plus 5 plus 5. Whew. So I'm going to do that. I'm going to get 3 plus 12 plus 3 plus 4 plus 5 plus 4 plus 4 plus 12 plus 4 plus 5 plus 5 plus 5 equals, you guys check my work. So 66, it's not squared because it's not area, it's just a round. Now, you don't have to do it. I just expanded it out. You can combine, the 3 4s, the 5 5s, and 2 12s, and so on. Okay, but just remember, don't forget to account. When we add, we got to go all add everything. This, 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 and this. Okay? All right, question 14. Miss Phillips is presenting cartoon pictures to all of her students who earned an A for the first quarter. She wants to attach each cartoon to a circular mat that has a diameter of 20 inches. What is the area of the mat? All right, so they already tell you what we're looking for, area. And remember, the area of a circle is pi r squared. Now, do we have r? No, we have d. 20 is d, but I know that half of d, meaning from here to there, okay, is the radius. Okay, from there to there. That's r, which in this case would equal 10. So then I'm just going to plug it in. Pi. And then remember, do the exponent first. So you're going to get 10 squared, which is 100 pi. And let's go ahead and just use 3.14. Okay, so remember it's that, so it's going to be 314 inches squared. All right, so this is a good question. We've got to compare these two things and find out which of these statements would be accurate based on our comparison. So it says, in Sally's neighborhood there are 2 swimming pools. Which of the following statements must be true about the 2 pools? So really we got to figure the area and the perimeter out of both of these. So this one would be 80 times 32. So 80 times 32 equals 2,560. Okay, and this one would be 76 times 36, which equals 2,736. So let me do 76 times 36. That's how we got that one. And that's how we got that one. Okay. And then we're also, because it asks about perimeter as well. So let's remember perimeter. So it's going to be 32, right, plus 80 plus 32 plus 80. All right, so let's go 80 times 2 equals 82. What? Sorry about that. We're going to go, that's for area. So for perimeter, we're going to go 160, because that's 80 and 80, plus 64, which should be 224. 160 plus 64 equals 224. So that's the perimeter. So that's the area, and that's the perimeter. This one is perimeter, so it's 36 times 2, which equals 72, plus 76 times 2, which equals 152. Alright, then I'm going to add those two together. 72 equals 224. Ooh, same perimeter. Okay, weird, right? Let's see what the question, I didn't even look at what the question, so we got the perimeter there. Okay, 76, 36. The area of the south pool is equal to the area of the north pool. South pool, north pool. Nope. All right. The area of the south pool is greater than the area of the north pool. That works. So, and we know the perimeter is the same, so perimeter is less than, nope. And perimeter is greater than, nope. Perimeter is the same. So our answer would be B. All right, question 16. The perimeter of this rectangle is 70 centimeters. What's the width of the rectangle? Ooh, good question. All right, so I know, here's how we're going to do this. I know a couple things. You always, in these kind of questions, you always got to go, what do we know? Well, we know that's 12, so we know that has to be 12, right? Okay, so that's 12 and that's 12. So far, I'm starting out with 70 equals these two plus these two. So I know these two, right? So I know that's 24 plus S, but there's two S's, so plus 2S. So now we're going to subtract 24 from each side. So 70 minus 24 equals 46. Okay, equals 2S. And now because there's two sides and they're the same. Whoa, what's going on there? And then 46 divided by 2 equals 23. Sorry about that. S equals 23. Okay. So the way we check that would be, I see how this problem is. This problem is it's crazy because this should be 23 and these should be 12. So don't go by what it looks like, right? 12, 24. So I've got to add 23 and 23, which is 46, 58, 60, 70. So that would make sense. So crazy looking because this should not be the same. It should be reversed. Go by what you know. Go by what they give you and not what it looks like. Question 17. Find the area of the shaded region. All right, so two shapes. Remember, always ask yourself what are the regular shapes that are involved. And then am I adding them together or am I subtracting them? In this particular case, they only want this part, the shaded area. Okay? There's no formula, there's no way to find that without finding the shape of both figures and then subtracting them. So we have a square. Alright. And what are the dimensions of this square? Well, we don't know, but we have the radius of this circle. And the radius is half of the diameter. So the diameter would be from here to here. So that would be 8 plus 8, which would be 16, which means from here to here is the same as from here to here, which would be 16, which means that this is 16, this is 16. Okay? So the square we know is s squared, or base times height, or length times width, one of those. So in this particular case, it's going to be 16 times 16, which our calculator tells us is, so that's going to be 256. Okay, so that's the area, inches squared. That's the area of the whole square. But remember, we are taking this part out. Okay. So we want to subtract that out. So we got to find that area to be able to subtract it out. So we got to find the area of the circle, which we know is pi radius squared. Okay. Now remember, do this radius first, squared first. So the radius is from halfway, right, to the outer edge. So that's 8 squared, which is going to be 64 pi, and 64 times pi is, let's use 3.14, is 200.96. So we're going to take 250, so that's the area of the circle. So we're going to take 256, which is the area of the square, minus 200.96, and we're going to get 55.04 inches squared. So the shaded part, now you can get even fancier and find out what each one of them is, because it's the square and the circle and they were all going to be equal or congruent. We could divide that by 4 to get 13.76. Ooh, that might be a good test question. All right, again, question 18. Find the area of the shaded region. All right, so I only see one different shape, but I see two of them, right? So I got this guy from there to there to there, okay? And then I got this one, which is from here, right? Oh, that's terrible. All right, so that one. And we're going to end, now I just colored in to make it look nice. So we're going to need to know, we got to take this one out. So we got to find the area of each triangle, right? It takes a long time. But, oh, better. Okay. So we want to subtract that out from the total. So we know the area of a triangle is 1/2 base times height. So, do we have a total height? We do, because it goes from here to here, right, of this particular triangle, from there to there, and we know that's going to be 5 plus 8, which would be 13. And then this is the base, so we're going to get 1/2 times 12 times 13. 1/2 of 12 is 6 times 13, which is going to give us 60, 78. Is that right? Let me check. 78. That would be the entire triangle without this blue shaded part that I've taken out. Okay? So now I've got to find actually the area of the blue shaded one, and subtract that from the overall triangle. So let's just redo the formula. 1/2, and I'm just going to plug it directly in. Base is the same, 12. All right, and this time, from here to here, which is the height of the blue one, right, is the same as it is from here to here. So that's 8. So the smaller triangle's 8. So 1/2 of 12 is 6 times 8, which equals 48. So now all I have to do is I have to take the overall triangle, the big one, subtract out the little one, and so I get 78 minus 48, which equals 30 centimeters squared. So that would be the area of the shaded region. So that's it. That's your test review. Hope that helped. Look it over. Miss Lipton, who's co-teaches with me, if you have any questions, stop by and ask her, or during second period, she's in here, or swing by Falcon Focus if you're not sure. She said she could answer a question or so. But good luck. Look over this. If you know how to do everything on here, you're going to do great on the test, and look forward to seeing you guys when I get back.